facilities that we don't actually operate. And please raise your hand. Did anyone do the research on the Tesla coil before they came in today? See a little bit of the background? Anybody? Oh, that's okay. So Brian is going to share and take the opportunity to ask him. They need it. Just bring that in here, guys. Thank you. Please take the opportunity. The opportunity to ask Brian questions. So, but you know what, Brian? Before you begin, Brent, I want to make it official. So I'm actually going to do. Sorry, guys. I'm going to do this. I'm going to keep this for the records of the college. So I'm going to introduce Brian. Let's see. Yeah, I'm going to do a very brief introduction. So just hold on. Don't worry. Okay. You've been here 30 years, right, Brian?
Yes.
Okay.
30 years, 1 month.
So I apologize. You didn't start it yet, did you?
No.
Okay.
You can always edit it. You can always edit it.
You guys don't want to block anybody. Okay. So I'm going to do a general welcome as an intro to this, and I appreciate you all being here today for this. So, ready? Good morning, everyone, and welcome to Physics 102, Physics of Sound and Light. We're going to take the opportunity today to learn about the Tesla coil from Brian Carpenter. Brian Carpenter has been with our department for the past 30 years, well, 30 plus years, right, Brian? Yes. And Brian will be retiring in 2 days. So please take the opportunity to ask any questions that you may, because Brian has lots of information to share about this unique apparatus. Thank you.
So, did anybody look up to Nikola Tesla? No? I guess they're one guy. I guess. Well, Nikola Tesla, he was the fellow that gave us our AC system that we use for distributing electricity. And he was what really sets him apart from other inventors of the time period was he understood something about resonant frequency. At certain frequencies, things become resonant, and that's both mechanical and electrical. He supposedly built a mechanical oscillator that he said would take down any building or structure just by finding the building's resonance and then pumping the building at its resonant frequency. But where he really shined was with this device, and all it is it's a coil and a capacitor that are operated at their resonant frequency. Now the coil is actually a transformer. It has a primary, which has just a few turns, and a secondary, which has many turns. So the voltage gets stepped up. And then when the primary of this device and these capacitors form a resonant tank circuit that then gets pumped at its resonant frequency. And the way we change its frequency is we take the voltage, the high voltage, off this input transformer, and we chop it up using this rotary spark gap. Now, I realize that no one can really see that down there, but it's like the distributor of a car. But instead of distributing the spark to different spark plugs, it simply turns it on and off. As the contacts line up, it arcs across it and then and energizes the coil. And then when the contacts are not aligned, the arc stops and the coil then de-energizes. And for this particular unit, we control the frequency that we're operating it at using this dial. And long ago, there used to be a chart that told us what number gave us what frequency, but it's been lost time, I'm afraid. And then we control the current going to the primary using this dial. And we have a picture back here of the coil in operation back when we first built it, before we had the nice isotropic capacitor that we have on the top there, courtesy of some engineering students who got really creative one day and welded two stainless steel salad bowls together to form a sphere. Well, we first fired it up at like 1 o'clock in the morning. We finished it, as all good projects go, we finished it at 1 o'clock in the morning. And of course, instead of going home and going to bed, we had to try it right away. So we dragged this thing down to the lower parking, to the area. We dragged it down to the area there where near the Chester building, in the parking garage, we have a fairly tall ceiling. Not necessarily lower parking, but there's a spot where lower parking and upper parking come together, and then it goes out to the back. And we plugged it in and started working with it. And at first, we found out we had too many turns in the primary, so we had to take a hacksaw and cut this off and relieve a couple of the turns of the primary. And then, actually, after that modification, it started working great for us. And we were able to jump sparks we were able to jump an arc 2 meters to a test stand. So that's quite a bit of voltage. Go ahead.
Frank, what was the point of the Tesla coil? Just to generate?
Well, no, Nikolai Tesla wanted to send wireless power because we were already sending wireless telegraphy or telegraphy. That's the word. We already had the wireless telegraph, and he envisioned us all being able to just simply put an antenna on our house and draw electricity in that antenna, and then we would have power in our homes entirely wirelessly. Which sounds great, right? Because unfortunately, it's a bit inefficient. It works, but it's a bit inefficient. But his idea was that they would set up power stations, which were just giant versions of these, across the globe, and they would operate it at the Earth's resonant frequency. And then at that point, then anyone could just simply put an antenna up, and then between that antenna and ground, they could draw a current that they could use to do work, to power things. And it sounds like a great idea on the surface, but unfortunately, it's highly inefficient, and that's why we're not using it. Go ahead. Oh yeah, they get their power from the transmitter. Absolutely. Early crucible radios definitely were powered by the transmitter itself, but you realize they don't require, they didn't have a loudspeaker. You had to listen to it with phones because it didn't have a lot of amplification. In fact, it had no amplification. They don't draw a lot of power. If you wanted to operate your electric drill or your air conditioner, you would need quite a bit more power. And that's where this system unfortunately breaks down. Now maybe they didn't envision all of the appliances that we would have today and all the things we would have to plug in. In those days, it was pretty much lighting. There weren't too many other things that they had to power.
What was the voltage that you got?
For a 2 meter spark, you can do the math. It had to be over 500,000. It had to be over 500,000 in order to do that. And actually, there's a picture up here if you want of it jumping. If you ever want to, this is always here. There's one on the other side there too. So anyone you can come and look at it if you wish.
Does anyone else have questions for Brian? Anybody want to ask anything more about it?
Yeah. How many amps was it running at? Now it draws 30 amps. When it's in full operation, we're drawing 30 amps. But due to inefficiencies in the system, the resultant current output is probably a lot lower.
You also know how many turns are on the secondary?
I used to. Because we had to count them on. And because we wound that coil. Like I said, this is a wooden form that the fellow that built it, Mark Coltars, he made a wooden form. You can't use any nails in it, so everything is glued and pegged together. And when we set this form up between two sawhorses, it was really easy to lift. And then we wound all these turns on there, and then we went to go lift it off the sawhorse and realized it was a lot heavier. It was really tough then getting it upright and getting it on the stand, just for the two of us. But I used to know how many turns was on there, and I just don't know. But to construct a Tesla coil, the important part is the resonance of the primary with the secondary, and the primary with the and the capacitors, which is the tank circuit. The secondary is we're just simply stepping up the voltage. You have so much voltage on this, and then you have so many turns per volt on this. So it's just a giant step-up transformer with the primary operated in a tank circuit with a capacitor at its resonant frequency. And the way Tesla did that was to use a rotary spark gap. Today it's possible to do it using solid state. We can drive it at a frequency that collects. This one particular one it's 650 kilohertz. That was considered high frequency today. Go ahead, young lady.
Sorry, we're out of time, Brian. I'm so
All right.
sorry. And then we have Shirley. Let's you are welcome after we are dismissed. You are welcome to stay and ask Brian questions, but let's give Brian a round of applause.